Welcome to Session 16. Exponential models appear when a quantity changes by a fixed percentage or fixed multiplier, not a fixed amount. Today we build growth, decay, half-life, doubling, and compound interest models. Linear models add a fixed amount. Exponential models multiply by a fixed factor. Increasing by 20 units is additive. Increasing by 20% is multiplicative. In a b to the t, a is the initial value and b is the multiplier per period. If b is greater than 1, the model grows. If b is between 0 and 1, it decays. Convert percent rates to bases. 4% growth uses 1.04. 20% depreciation uses 0.80 because 80% remains. To recognize an exponential table, divide consecutive outputs. A constant ratio of 0.75 means the model retains 75% each period, so it decays by 25%. For half-life, the exponent counts how many half-lives pass. For compound interest, divide the annual rate by the number of periods per year and use the total number of periods. Your turn. A population starts at 500 and grows 6% per year. Pause and build the exponential model. 6% growth means the multiplier is 1.06. With initial value 500, the model is P of t equals 500 times 1.06 to the t. Session 16 recap. Linear adds while exponential multiplies. In a b to the t, a is the initial value. Growth uses 1 plus r, decay uses 1 minus r, and half-life or compounding exponents must count the right periods.